Good morning, students. Today we are going to learn steel. First important is that whenever we are going to understand something, we should know why we are studying that. So, steel, why we are studying steel is nothing but yes, of course, we are having contents or the explanation or the theory regarding steel. But why it is important? It is important because as per the manufacturing industry concerned, most of the manufacturing industry is mechanical point of view. Steel is a very important element, so we should know what are the different types of the steel and why what are these applications and all. So we'll see in this session regarding the types of the steel based on the percentage of the composition of carbon. So first important question that I will pose is, what is steel? So whenever this question will come, now here the question is given, what is steel? Now I'll try to write the answer is, it is an alloy of iron and carbon. So in this case, you can see it is an alloy of iron and carbon, but the important one is, here we are looking for the steel which is based on the types of the steel based on the percentage of the carbon. Now what based on the percentage of the iron and carbon, it is being classified as cast iron and steel. So the alloy in which the carbon percentage more than 2, no sorry, less than 2 is called as steel, and of course more than 2 is said to be a cast iron. So this is the first fundamental thing that you should understand, that steel is an alloy of iron and carbon. What is an alloy? Alloy is a microscopically heterogeneous mixture of two or more elements, and macroscopically homogeneous mixture of two or more elements. So this is what is the basic. Then we see these first types, low carbon steel. Here we can see that it contains 0.41% of the carbon, cannot strengthen by heat treatment process, and it has excellent formability. The formability process used in the form of cold rolled steel is the main application you can see. Then its microstructure is very important, ferrite with a small amount of perlite, and it has excellent weldability. So you can see that microstructure of the low carbon steel. So this lamellar nature of the perlite you can notice over here. Now you can see the mechanical properties. Yield strength is having 200 to 300. Now try to recall that stress strain curve, in that the strength yield strength is explained. So it is 200 to 300, and tensile strength is 300 to 370, and its percentage elongation is 28 to 40, which is given. Its application: stamping of automobile refrigeration, tin cars, and corrugated steel is the application. Now we see dual phase steel. So now the efforts are made to develop the higher strength of steel without an appreciable loss of the formability. So the modified process, and which are adapted for the low carbon steel, based on the low carbon steel to realize a different microstructure. So you can see a dual phase steel where you can see a martensite Iceland. You can see that these are the Iceland in a matrix of ferrite. So this is a matrix of ferrite. In that you can see the martensite. This is the magnification which is given. So you can see the small martensite Iceland. So you can see that the structure. You can see the steel type, low carbon steel, and you can compare. Now based on this modification, we have good yield strength, tensile strength, and its elongation. So it has somewhat uh, good ductility, you can say. So because parallelly you are getting strength, but here you can get is percentage elongation. Then you can compare, you can easily compare here the low carbon steel and your dual phase steel. You can see that even if it is having low ductility, but it is having very good strength. Okay, so you can use this dual phase steel and low carbon steel. So right now don't go with this microalloy, we'll explain it in the next slide. So this is a stress strain curve, try to recall it. So according to what is the data that is given, you can see this structure. Now this is what we are having. It's a low ratio yield strength to tensile strength, high work hardening rate and high tensile strength and large uniform elongation. Its application, again bumpers, wheel disc, door panel, you can see the weight saving as much as 10% and consequently significant energy savings over here. So it's best to use that. And you can see the famous mild steel, again 0.15 to 0.25% of the carbon, no, not heat treated, it can't be heat treated. Then microstructure contains 25% of the fine pearlite in interspread of ferrite matrix using large tonnage of structural purpose, and it has excellent weldability. Now you can see the strength over here and the percentage elongation also. So you can see this comparison between low carbon steel and mild steel based on the so due to higher carbon content, this is important, mild steel have a higher strength but ductility is lower. So you can go with the depending on the application, depending on the values, you can go with the that particular application. You can see the famous graph, which is the carbon percentage with the strength and this hardness number that is in terms of the which is been tested with the Grinnell test. So you can see the percentage reduction in the area, elongation, yield strength and tensile stress. So this gives you the data regarding what happens if the carbon percentage is more and carbon percentage is less. So you can have the typical, you can select the proper suitable material which is required that you have done in your first session. So now you can see these are the application, you can go with the application. Now microalloy steel. Now what is microalloy steel? That is again see the now first you are seeing low carbon steel and what we are seeing as dual phase. So dual phase is a part of your low carbon steel. Now is mild steel. Based on that we are having the improved one, improved mild steel, you can say it's microalloy steel. This has a new class of the steel known as microalloy steel. The basic composition of mild steel is small amount of the strong carbide forming elements, so that is not, you can see that this carbide forming niobium vanadium, and because of which these the some certain amount of properties is going to change. So the total concentration of the microalloy is less than 0.2%. This is important. So again it is important that microalloying does not significantly increase manufacturing cost because of this less percentage of this one, right? So these are the typical mechanical properties. Now you can see that it has certain elongation but has a strength. Now you can go with the strength. If you want to increase the strength, you can go with the microalloy steel by using these kind of the carbide forming elements. Now you can see the grain size, now because of which the grain size has been increased. So ASTM you can see 12 to 14. So because of which it is increasing the size of the that alloyed steel, mild steels. So these are the formulas that is given. So this is the according to this formula of the grain size. So you get fine dispersion of the level curves. Now you can have strengthening mechanism. You can have various strengthening mechanisms so that you increase the strength. So this total 525 is given. Iron lattice contribution 35 megapascal. So we can increase this much of the strength values of it. So strengthening mechanism, grain refinement, it will decrease in grain size. You can see it. Formability, the high strength of the microalloy steel associated with the lower elongation values. Consequently, they have poorer formability than the conventional low carbon steel. So dual phase steel, in contrast, have a combination of the high strength and formability. So this is the comparison, the application of the steel which is given. So available in various product forms, sheet, bar, plate. Now let me remind once again that this graph we have seen about the microalloy steel. Now you can see that in between this we are having low strength. You can see the low strength based on the dual phase. So what we learned here is the types of the steel, and more importantly what we have seen is that based on the application that we want, we can use that steel, whether we want a higher ductility or higher strength of the steel, and by considering the manufacturing cost also. So you have various mechanism, that is what we call as a strengthening mechanism, and based on that you can have, now let me go with this previous one. So you can see these are the strengthening mechanism that you have learned. These are the names that is given: grain size, dislocation, precipitation and all. and important one is that the manufacturing cost that we need to understand. You can see that these are the allowing elements, but the allowing elements is, you can see here, the total concentration is less than 0.2, so this microbial does not significantly increase in the manufacturing cost. So this is what we targeted at.